students, Namaskar. I hope you are all well and in sound health. And you all must be excited for learning as well. So students, today we are going to talk about Chapter 1 of Science of Class 10, Chemical Reactions and Equations. Let us see what we are going to learn in this chapter. First of all, we are going to talk about chemical equations, and then different types of chemical reactions will be discussed, and after that we will also discuss the topics corrosion and rancidity. First of all, we shall talk about few chemical reactions. You all must have seen changes around you, and there are certain changes which can be reversed, that is, the substance can be brought back or returned to their original form. Whereas there are certain other kind of changes where the substance cannot be reversed back or the substance cannot be returned to its original form. For example, if a brick is broken, like during construction, so this brick can be joined by using cement or any other method. But if you have an iron almirah and over a period of time it gets rusted, so do you think that it can be reverted back or we can get iron again from the rust? Have you ever thought about this? Do you even ask these kind of questions? If not, then you must start thinking. Why there are certain changes which can be reversed or are reversible, whereas there are certain other kind of changes which cannot be reversed or are irreversible. Like, we all have seen matchstick in our house. When we light a matchstick, as I am lighting a matchstick here, and see it catches fire. And what change do you observe in the matchstick? Look carefully. The wooden matchstick changes into ash. You must think that why does this happen? So children, now you think, can we again make the matchstick from the ash? Just think. Do ask your teachers these kind of questions. Start asking questions, think and understand, because science is not a subject of merely learning the concepts and facts. Rather, the beauty of science lies asking questions and seeking answers. So, you must ask these kind of questions to your teachers. You have already studied about different kind of changes in class 9th, where we have studied about physical and chemical changes. Okay, now you think why we cannot reverse some of the changes, whereas some other changes can be reversed. So, to see a few chemical reactions, we have brought some material with us. With the help of this material, we will try to see different kind of chemical reactions and their results. Students, there are three components of science. First, basic component is vocabulary. Second component is observation. And third component is analysis. Our entire science revolves around these three components. Now, we will tell you what is vocabulary. Vocabulary means the names of equipments and apparatus which we use in our laboratory and their uses. Like, I have a test tube in my hand. Why do we call it a test tube? Do you know that whatever tests or experiments we conduct are actually conducted in this test tube. And since it is tube shaped, so what do we call it? Yes, a test tube, because we use it to carry out various tests. Similarly, if you observe carefully, I have two glass utensils here. Both are cylindrical in shape. But if you carefully see the mouth of these utensils, the first one is completely circular, so it is a simple glass or jar. But the other utensil, if you see carefully, it has a beak-like structure near its mouth. So it is called a beaker. Now these beakers come in different sizes like 50 ml, 100 ml, 250 ml, 500 ml and so on. Now if you see carefully, these beakers have measures written on them: 10, 20, 30, 40. But I said that this beaker is of 50 ml. And you can see that there is a large amount of space after 40 ml. So, when we fill this beaker to its full capacity with water, then the volume of water in the beaker will be 50 ml. Similarly, in this beaker also, scale is only up to 80 ml. But when we fill it completely, the total measure of the liquid will be 100 ml. Similarly, we have beakers of large capacity also. Like, we have beakers of 500 ml capacity, but these beakers do not have scales printed on it. When we fill these beakers to their full capacity, the measure of the liquid will be 500 ml. So students, you must ask your teachers about these kind of questions. You must have seen beakers with no scale on it, and you must ask about the capacity of these kind of beakers. So students, let us see another apparatus which is used in our science laboratories. See, this is a conical flask. We call it a conical flask because the shape of this apparatus is like a cone. This conical flask also has a scale printed on it, and the capacity of the flask is 50 ml. This conical flask also come in different capacities or volumes, which are present in our laboratories. Whenever you go to your school laboratory, you must carefully observe these apparatus and see how they are used. So let's go ahead. Now I have another apparatus here, and it is called a spirit lamp. I have a new one and an old one. It is called a spirit lamp because it is filled with spirit, and spirit is used as the burning liquid or fuel in this lamp. The spirit in this lamp burns, and we use it in different kinds of experiments. So I am lighting this spirit lamp here. See, this burns with ease, and flame is blue near the wick and yellow on the top. So children, as we perform different experiments, we get to know about these equipments and apparatus, and it improves our vocabulary. Now look at this. This is a rod made up of glass. So This is called glass rod and usually used for stirring the liquids or solutions. Stirring is used to mix two or more components in a solution. Similarly, we have another apparatus called spatula. It is a small spoon-shaped apparatus used to take out chemicals from their packing and add to the test tube or beaker for experiments. Okay, now you see what am I holding in my hand? Yes, it is a test tube. And I am holding this test tube with the help of another apparatus called test tube holder because it is used to hold a test tube. So, this is a test tube holder which is used to hold a test tube when we are heating it. So, children, like this, we have a large number of apparatus which we use while performing different kind of chemical reactions. Now I have another apparatus, and how does it look like? Absolutely right. It looks like a dropper which comes along with medicines. So, this is a dropper. Why do we call it a dropper? Because by using this, we can add any material to a test tube or beaker drop by drop. Like this, students, our vocabulary improves while we perform different experiments or use different kind of apparatus. We get familiar with the names and uses of various apparatus and equipments which we use during performing the experiments. Test tube because it is used to perform tests. Beaker because it has a beak shape near its mouth. Since it is cone shaped, so it is a conical flask. And this is a spirit lamp because it has spirit and it burns with the help of that spirit. So like this, our vocabulary is improving as we are proceeding. Now, let us perform activity 1.1. In this activity, we have to burn a magnesium ribbon. In this activity, we will see what products are formed when we burn a magnesium ribbon and how they are formed. Materials required. For this activity, we need spirit lamp, matches, magnesium ribbon roll, sandpaper, tongs or holder. You must be wondering, why do we need a sandpaper here? Look at the magnesium ribbon carefully. I have two different rolls of magnesium ribbon here. One of them appears dull, whereas the other one is shiny. The dullness of the magnesium ribbon is due to the layer of magnesium oxide when magnesium reacts with oxygen of the atmosphere and forms a layer of magnesium oxide. Students, you must have observed that when you bring a new aluminium utensil, it shines, but over a period of time, the aluminium utensil becomes dull due to the reaction of aluminium with oxygen of atmosphere, and it forms a layer of aluminium oxide. So, oxygen in atmosphere reacts with metals and forms a layer on the metal, and metal becomes dull. But students, does every metal lose its shine when exposed to air? Well, you need to find out. So, let us perform our activity and observe how magnesium ribbon burns in air. magnesium ribbon is flat, ribbon-like, and let us take a piece of this magnesium ribbon and clean it with sandpaper. So, I am burning magnesium ribbon without rubbing with sandpaper. And you see, this magnesium does not catch fire easily. Now, I am taking another magnesium ribbon and I am rubbing it with sandpaper. So, I am thoroughly rubbing this magnesium ribbon to remove the layer of magnesium oxide, which is developed when magnesium reacts with oxygen of the atmosphere. Students, you have observed that when we burn magnesium ribbon without rubbing, it burns with difficulty because magnesium oxide raises ignition temperature of magnesium. Now, why does this magnesium react with oxygen? Everything in nature tries to stabilize itself. So, magnesium reacts with oxygen to form a stable, non-reactive layer of magnesium oxide which protect the underlying metal from further reaction. That is why we use sandpaper to remove the layer of magnesium oxide and expose fresh magnesium layer, and this magnesium easily catches fire. Now, we will collect this white powdery substance formed after burning magnesium ribbon. This white powdery substance is magnesium oxide. Now you think, can this white ash again be changed into magnesium ribbon? No. Students, always take care that whenever you are performing any experiments involving fire, please keep a bucket full of water and sand nearby, because if fire goes uncontrolled, we may use them to put off the fire. So you can see that they are available here also. Now let us proceed with our activity. So we have seen that magnesium burns with oxygen with a bright white flame, and the white colored powdery substance is formed, which is magnesium oxide. Now let us test the chemical nature of this white ash, that whether it is acidic or basic. To test the acidic or basic nature of a substance, we use litmus paper. Do you remember litmus paper? Yes, you have already learnt about the litmus in your class 7 in the chapter Acids, Bases and Salts. Now you tell me, students, from where do we get litmus? Absolutely correct. It is obtained from lichen. The dye obtained from lichen is used to make litmus paper, and this paper is available in two colors, blue and red. Litmus is a purple colored dye from which different colored papers are obtained. Red litmus changes to blue in basic solutions, and blue litmus changes to red in acidic solutions. So here you can see I have both type of litmus papers, red and blue. Now let us test hydrochloric acid with these litmus papers. I am adding few drops of hydrochloric acid in water and testing with red and blue litmus paper. The color of the blue litmus changes to red, which shows that hydrochloric acid is acidic in nature. Now we will perform activity 1.3. In this activity, we are going to observe the reaction between metal and an acid. Metal used is zinc and the color of this metal is silver grey, and you can see that it appears very shiny or lustrous. Acid used here is hydrochloric acid. Other acids available are sulfuric acid, nitric acid, etc. These acids are available in the concentrated form in our laboratories, but when we use them, we add water to these acids and we use them in dilute form. What is the difference between concentrated and dilute acid? Concentrated acids contain more acid and less of water, whereas dilute acids contain less of acid and more water. Concentrated acids are dangerous and we need to handle them cautiously. How to make dilute acid from concentrated acid? To make a dilute acid, take water in a beaker and add acid drop by drop. Dilution of an acid is an exothermic process and lot of heat is generated. Now you must be wondering why we cannot add water to acid. Now, dilution of an acid is an exothermic process, and during this process a lot of heat is generated. So, if we add water to the acid, there will be local heating, and due to excessive heat, the contents may be spilled out or the glassware may break off. So, that is why we always have to be very careful while we are diluting an acid, and always acid should be added to water drop by drop. Take a conical flask and add few zinc granules to it. Now add dilute HCl drop by drop. You can see, children, the reaction has already started and we can see the formation of bubbles in the flask. Ask your teacher about these bubbles and you also think about this change. You must be knowing that bubbles are produced when a liquid substance changes into gaseous form, like boiling of water. Zinc reacts with hydrochloric acid to form zinc chloride and hydrogen gas, and it is written in the form of an equation as Zn, that is zinc, plus HCl, that is hydrochloric acid, give ZnCl2, that is zinc chloride, plus H2, that is hydrogen gas. This hydrogen comes out in the form of bubbles. So, let us try to understand the chemical reaction for this equation. Whenever there is a chemical reaction, we can observe following four changes: change in state, change in color, evolution of a gas, change in temperature. When two or more substances react together to form new substances in a chemical reaction, the substances which react are called reactants, and the substances which are formed after the chemical reaction are called products. The chemical reaction is indicated with the help of an arrow between reactants and products. For example, when magnesium reacts with oxygen, we write reactants on one side, that is Mg magnesium plus O2 oxygen, and these two react together to form magnesium oxide, which is written on the other side. Students, now let us understand the importance of a balanced chemical equation. Before that, let us try to balance a chemical equation. Fe is the symbol of iron plus H2O is formula of water, and these two react together to form ferric oxide or iron oxide and hydrogen gas. Before balancing a chemical equation, first we should know the atoms participating in the reaction, their quantity in reactants and products, and write this information in the form of a table. In this chemical equation, our reactants are Fe, iron, and H2O, water, and the products are Fe3O4, ferric oxide, and H2, hydrogen gas. In reactants, the number of iron atoms are 1, hydrogen atoms are 2, and number of oxygen atoms are 1. The reaction is Fe plus H2O produces Fe3O4 plus H2. In the products, the number of atoms are iron atoms are 3, there are 4 oxygen atoms and 2 hydrogen atoms. To balance this chemical equation, the number of atoms on reactant side and product side should be equal. After learning about the importance of balanced chemical equations, students, now we will learn about different types of chemical reactions. First is combination reaction, second decomposition reaction, third is displacement reaction, fourth is double displacement reaction, and fifth is redox reaction. So children, here we complete our today's topic, and rest of the chapter will continue in the next part. So stay safe and stay healthy. Thank you.